Experiment is about the law of conservation of mass in open and closed systems, and for the first experiment we are going to use calcium chloride and sodium carbonate, and here's the equation: CaCl2 plus Na2CO3, and the products would be calcium carbonate and sodium chloride. And over here in the reactants, the molecular the ratio is 1:1, and for the calculations we're going to have 5.5 grams of calcium chloride in 50 milliliters of water, and 5.3 grams of sodium carbonate in 10 milliliters of water. So there's a 5:1 ratio here. So that's what we're going to do. And now we're going to measure out the chemicals. In the calcium chloride, we're going to first use it, making sure, accounting for the balance. Tiered. Then we're going to measure out 5.5 grams of calcium chloride. One 1.3, 2.3. We went exactly 5.5 grams, 5.6, very slightly over. And now we are going to measure out 50 milliliters of water in this graduated cylinder. So there it is. We have a flask to mix all the chemicals. We have a stopper here, and first we are going to put the calcium chloride. It's not exactly working, but it's close enough. Now we're going to combine this to make the calcium chloride solution. You can see there's a reaction. Right. Now we're just going to put a stopper on it for now. Now we're going to look at sodium carbonate. First we're going to stir it to make sure it's evenly blended. And now we're going to look at sodium carbonate. You have it, and now we're going to use another weighing board. Turn it on. Use the tear function. Now we're going to measure out 5.3 grams of sodium carbonate for 10 milliliters of water. .8 grams. actually going to get rid of 5.5, 5.4 grams. Should be enough. 5.2 grams. That's close enough. So now we're going to measure out 10 milliliters of water. So hope I didn't spill it like last time. Little excess. Now we have it. Roughly 10 milliliters of water. We're not going for exact measurements here. And now we're going to mix the two to get a solution. Putting the solid sodium carbonate in there first and then put in the water. Certainly better than last time. Making sure to keep the away. Notice there's an obviously a lot of precipitate solid remaining. You have to stir it first to make sure there isn't much leftover solid. There you have it. You have both calcium chloride solution, sodium carbonate solution. In this series of experiments, we are going to use two equations to test the law of conservation of mass in open and closed systems. And in the first equation, we're using calcium chloride plus sodium carbonate as the reactants in a double replacement equation yielding the products of calcium carbonate and sodium chloride. And what we're going to do here is we have calcium chloride solution and sodium carbonate solution. We made the solutions in another video, so you can click on the link in the description to see how I made the solution. And for this experiment, we're going to use a closed system. We're going to use a test tube in an Erlenmeyer flask. And then we're going to shake it to see the mass it's sealed. And then we're going to use a test tube in a beaker. It's open system. We're going to see if the mass changes or not. So for both experiments, we're going to use 25 milliliters of calcium chloride for 5 milliliters of sodium carbonate. So first we're going to measure out the calcium chloride using a graduated cylinder. Yeah, that's more or less right. Okay. So now we are also going to put that into the flask. Now we're going to measure out another 25 milliliters of calcium chloride for the open system. Right, now we're going to put it in the beaker. Right, now we're going to test the closed system. with the sodium carbonate. First we're going to measure out 5 milliliters of sodium carbonate. We're going to use a pipette because the volume is pretty small. There, that's 5 milliliters. Now you have a test tube. We're going to eject this all into the last little bits over there. We're going to put this into, use a cap first. Leave it aside in the test tube rack. Now we're going to use another one. Sodium carbonate, another 5 milliliters. It's 5 milliliters. Now we're going to inject it into this test tube. Yeah. Not gonna get the last bits, and now we're going to test in a closed system first. We're going to be measuring the mass. Keep it tilted. Turn on the scale. First, keeping on the lid to make sure the system is closed. Now measuring the mass of the total apparatus. We have 290.7 grams for the beginning. So experiment 1, we have 290.7 grams. Before the experiment, before the reaction, and now we're going to turn the whole apparatus upside down to see how the reaction will occur. This is tightly sealed. This is clearly a reaction has occurred. 290.8, maybe like a 1 gram difference. It's not a big difference. There shouldn't have been an error at all. Maybe it's just human error occurring. So that's the results for experiment number 1. For equation number 1 in a closed system, and now we're going to test this with an open system. We had our beaker, a test tube of sodium carbonate. Now we're going to put this. Now our mass is, for the second open system, 165.6 grams, and this is before the reaction. And now we're going to be testing the mass after the reaction to see the mass increases or decreases. Mass changed slightly, 155.2 grams. Actually, no, the mass didn't change that much. Same, very insignificant amount of mass change, 165.4 grams. It seems though even the system is open, nothing escapes because there's only solids and liquids. They won't escape in a vapor form. So now we have the results for the first experiment. We had 90.7 grams for the first experiment in a closed system, leading to 290.8 grams after the reaction. And in the closed system, an open system, we have 165.6 grams, then 165.4 grams. In an open system, the mass will only change generally if there is a gas or vapor emitted from it, like generally if it's like a acid-base neutralization reaction when the CO2 escapes. That's going to be our next equation that we're going to cover. This is the second part of the law of conservation of mass experiment, and we are using hydrochloric acid plus sodium bicarbonate. Just you can use regular old baking soda. In a neutralization reaction, sodium chloride plus carbonic acid, which dissociate into carbon dioxide and water, H2O. And right now we're going to do the experiment with 5 grams of sodium hydrogen carbonate powder over here, with 5 grams or 5 milliliters of hydrochloric acid solution, which was made before. So right now we're going to do open and closed systems. This was the results of the previous experiment, and now we're going to use a flask and a test tube for the closed system, and a beaker, open beaker, and a test tube for the open experiment. So right now we are going to measure 5 grams of sodium bicarbonate. Making sure to tare it using a spatula to measure out 5 grams. For 9 grams. There, 5.1 grams. Oh well. Okay. So now we're going to put this into the beaker first. Or rather the flask. We're doing the closed system first. That enter here. And now we're going to measure out another 5 grams of sodium bicarbonate using the spatula again. Again, same results. Okay. So now we don't need this anymore. Put it back. Now we're going to put this into the beaker. Right, now we're going to measure out hydrochloric acid solution. Very volatile substance. You'd be very careful here. Okay. So now we're going to put this into here. Measure out 5 milliliters of diluted hydrochloric acid solution, 10%. So 5 milliliters. A little excess. I'm going to put it into a test tube. Right, now we're going to cap this very tightly. Second time. Another 5 milliliters. A little too much. Another test tube. We are going to inject all of this. Again, capping it very tightly and sealing this beaker because it is very dangerous. Right now, for the first experiment, we are going to measure the mass, width, and with the cork, obviously. So the mass for the second experiment in a closed system is currently 224.5 grams. 224.5 grams. And then when we mix the substances together, making sure the cork is sealed extremely tightly, we're going to tip this upside down. You can see the fizzing. And did any mass change? Not significantly. No, not much mass changed. You can see there's 224.5, the exact same mass. Even though this is a neutralization reaction and gas would have escaped had it been an open system, no mass escaped because it was closed. Okay, so for the second part of this experiment, we are now going to test in an open system. Now we're going to see the mass, hydrochloric acid and sodium bicarbonate. The mass is 192.9 grams. And now we are going to test the reaction. Make the test tube away from you. Making sure to keep the test tube in the apparatus. Now the mass is 192.6 grams. Not a big difference, but there's still a difference. So apparently the carbon dioxide given off in this equation led to a 0.3 gram difference. And the conclusion for this series of experiments is that in our first experiment series, we had calcium chloride and sodium carbonate in a double replacement equation, yielding calcium carbonate and sodium chloride. In both the open and closed systems, there wasn't a significant difference in mass because both of the reactants were liquids, and now you have a liquid and a precipitate. And even if the system is open, a liquid or a solid won't really escape from it, so there's not a big difference. However, in the second reaction where you have hydrochloric acid and sodium bicarbonate. In the neutralization reaction, acid and a base, you have sodium chloride, salt, and carbonic acid would dissociate into carbon dioxide and H2O. The carbon dioxide escapes. The weight the weight of the gas isn't that much, but you can still see a difference in the 0.3 gram difference. Here, that's the carbon dioxide escaping. And yeah, so that's the conclusion for this series of experiments on the law of conservation of mass in open and closed systems. Thank you for watching this video.